Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem trapping rainwater. So the problem statement says that given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. So we can see in the input we are given just height arrays, and these height arrays tell us the height of the buildings. And in the example 1, all the buildings are colored with black color, and we have to tell how much water can be trapped. Let's say the area of the water, we have to tell how much water can be trapped between these buildings. So we can see from the example 1, if the black ones are the buildings, we can see the height of the first building is 0, next building is 1. These are colored with black, and these heights are given in the height array. And how much water can be trapped here. So in this example we can easily see that between this building block and this building block only this amount of water can be filled, because after it will overflow. So here we can see the area of the water is 1, here also 1, 1, 1, 1 and 1. So it totals to 1 plus 1 plus 1 plus 1 plus 1 plus 1, 6. So here's the area of the water is 6. So how we can solve this? So let me take an example. I've taken the same example 1 here. So what can I think of? So if I tell you the basic idea, we have to first observe. The first observation after seeing this trapping rainwater should come into our mind is, suppose we have two buildings, and these two buildings are there. Height, let's say, is 1, and here the height is 3. So how much water can be trapped between these buildings? What do you think? Water will fill here until only here. After that it will just overflow down this out of the boundary. So we can say the water can be filled up to the height of the minimum height of the building, with the minimum height amongst the left and the right. So the water can be filled till the height 1 here, because after one height, after the water has reached height 1, it will just overflow. So we can say that height of the water can maximum be 1. And how I'm saying that this 1 is coming? This is coming from the minimum of these two heights, 1 and 3. So maybe there can many more buildings. So let's say this one, or let's say there is no building here. So minimum maximum water can go up to this 1 level. So what I just observed, that water area, and we also know that area is what? Height into width, and width is always, width of each bar is 1. So width of each bar is 1. So we can say that the area is only the height. So width is 1. So we can say that if we anyhow calculate what's the height of the water in the ith building, above the ith building, then we can say that area is only the height. Alright, so area is only dependent on the height. So what I just observe here, that the water level can reach maximum water level can reach here is the minimum of the two buildings, left and right building. And these left and right buildings are what? This left side building is that building on the left which has highest height. Alright, so I would say here minimum of L max and the right max. Alright, so what I said here, if I'm standing at any index, I, let's say I'm standing at this ith building, what I will do, I will try to figure out what's the highest building in the left. In the left, the highest building is this, let's say L max, and in the right, the highest building, I have the R max. Alright, so now I can know that the maximum water level can raise up to the left max. So left max in this case is 2 and here it is 3, because minimum of left max and right max we can say is 2. So in the ith building, this we can see the height of the building is 0, so water level will be up to height 2. Alright, and if we check the water level, if I is this, so I'm sorry, so we can say that here the water level will also be left max, minimum of left max, right max, but we can see the water level is still 2, but we need to calculate how much water will be trapped here. So we count this building height also, because water is trapped above the building, so we should ignore this building height also. So I would say that minus height of the own building. Alright, so we need to just calculate the water trapped above the building. So in this case, when I was here, so we can say that height of the building was 0, so water level will be just left max, minimum of left max and right max, minus 0. But here a building is also there, so we need to subtract this height of the building. So we have just made one observation that between two buildings the maximum water level can raise up to the height of the building amongst left and right building. All right, so water level will only raise up to the minimum of left max and the right max. All right, so now this observation is done. I hope you understood. Now what will be my second step? So we understood that if we are standing at any ith building, the height is depending on the left max and right max. So if we are standing at any ith building, we need to know left max and right max. So for that, if we are standing at here, so either we go from here to the leftmost and check which building has the highest height, and go on the right and check which building has the longest height. So this is the case, but this will take big of n square time complexity, because I will be iterating from first building to the last, and for each building we have to go to the left and go to the right to calculate the L max and the right max. So this will take big of n square time complexity, so this will not be good. So the next, what we say, optimization, rather than calculating for each I left max and right max, the next optimization we can think of is we can pre-compute left max and right max arrays. So using prefix arrays and suffix arrays, what we can do, we can create L max array and right max array. For calculating L max array, we can iterate from left to right and keep track of the maximum height found. Alright, so if you are standing at the first building, we can store left max ith building's height as the first height only, this is 0, and as moving we can just store what is the maximum left height we have found. So this will be 1. The height of this building is 1, so maximum of the previous one and the current, so this will be 1. Moving ahead, this will be 1. Moving ahead, now it will come 2. So similarly we will just keep track of the if we are standing at any height building, we will just keep track of which building has the longest height in the left by using this left max array. And similarly for this will be our prefix array. All right, and similarly for calculating the height, for calculating R max for each ith index, we can iterate from right to left, and our first here the last can be the height of the last building, that is 1. And as moving from right to left we can just store the maximum height till found. So here this, so at any ith building we can just know that standing here we can easily know which building has the longest height in the right. All right, so using this prefix and suffix arrays we can easily reduce this time complexity to linear. But the problem here is also this is acceptable, but this can be more optimized. So we know the time complexity is linear, but extra space we are taking for these suffix and prefix arrays. So space complexity we can say that it is coming big O of 2n due to calculating this left max and right max arrays. So this will be acceptable. Now how we can reduce this space complexity? Is there any method? So I would say yes, there is a method. So there is a method, 2-pointer method. What we will do, I will tell you. So first of all I would like to take this below to understand it clearly. So I think I have to again copy this as whole. What happened? So let's do it here only. It's not shifting right now and I don't want to waste the time. So how we can reduce this? If I tell you the logic of reducing the space complexity, suppose what I told you, our water at any ith building, above any ith building, will be the minimum of left max and right max minus the height of the building. So so what if we fix, let's say our right max is fixed and all left buildings are either equal to this right building or less than this. So at every ith building when we go and calculate minimum of left max and right max, so at any ith building if we try to calculate minimum of left max and right max, this will only come height of the, this will what it will come. If we try to calculate minimum of left max and right max, it will be nothing but left max. Why? Because we know that we need to calculate minimum of left max and right max, and if we have fixed our right max, fixed our right max, we know that all the left buildings are lower or greater than equal to this, so we can say that L max is always going to be less than equal to right max. So the minimum of this left max and right max will always come left max. All right. Similarly, if we fix our left building height, left max building height, and we know that all the right buildings are either equal to this left max or smaller than this. So we know that all the left building are right building, so are less than or equal to this left max. So while calculating this minimum of left max and right max, this will always give right max. All right. So using this observation, we can reduce our space complexity and we can use two pointer technique. So in the two pointer technique, what I will do, if I explain you here, so what I'm going to do, I'm going to just take two pointers, and my first pointer left will be at the first building and right will be at the second building. All right, my L will be at the first building and right will be at the second building. Now what I said, that if I fix any building, then if I fix any right building, we are sure that all the left buildings are less than equal to this right max building, the minimum is always going to come left max. So what we will do, if we are at any left or right, all right, we will store a variable left max and right max, because we need this in our formula, so this has to be declared. So let's say these are currently 0 0, and I took two pointers left and right. So at every iteration, when left is here, right is here, what I will do, I will calculate left max and right max. So left max, we all know, will be the maximum of left height and the L max. So in this case left is 0, and in this case right max is going to come 1. So now we know that right now our case is like this: our left max is 0 and our right max is fixed of height 1. So what I told you, I will, when in this case left max is less than equal to right max, or left max is less than right max, so while my right max is greater than left max, what I will do, I will keep going from left to right for calculating the wattle trapped above the building. What I'm saying, that for instance I am going to take my right building for I'm sorry. So I'm saying that for an instance, what I will do, while my right max is this, and right max is going to come greater than left max, I'm going to move left pointer again and again and again and again, because I know that my left max is greater than that my left max is smaller than this right max. So I will keep moving my left and keep calculating the wattle trapped. So in this case my wattle trapped will be the minimum of right max and left max. So the minimum will come only left max. So that's why I will keep calculating my wattle trapped with the formula L minus the height of the building. All right, so I will calculate this way only. And when in any case my left max, in my any case when left max is going to be greater than the right max, I would know that my right buildings right maximum is less than the left max. So all the right buildings are going to come less than this left max. So I would say I will keep moving right pointer, and I will calculate the wattle trapped by using the formula the right max minus the height of the building. All right, so that's why I'm using this two pointer technique. So if I tell you dry run, so my left pointer will be here, right pointer will be here. In each step I will update my left max and right max. So in this case left max is 0, right max is coming 1, and now I will say that my left max is less than the right max. It means I will fix my right max and I will calculate my answer based on the left pointer, and I will keep moving the left pointer, because my maximum building height at the right is fixed. So my water, if I calculate water trapped, total water trapped, so in this case what will be this minimum of this will be, I'm saying 0, and height of this L is 0, so water here comes to be 0. And now what I said, L max is less than the right max, I will keep moving left. Now again my left max will be increased. So in the else case I am moving right pointer, you can move any pointer. So in the else case I'm going to calculate the moving the right pointer, but before moving I should calculate the water. So it will be right minus height of the building, so 1 minus height of the building is 1, which will again come 0. Now I will move right pointer and update my right max as 2, and now water will be my I know that my right max building is of height 2 and the left building is of height 1. So I know I should move my left pointer and calculate the water trapped based on the left, because water is calculated on the based on the minimum height building. So here now my water trapped will be minimum of these two, that is 1 minus the height of the building currently which is L, which is 0. Now I will keep moving L. Now here again I will update my left max and right max, and I will see there is no change. And now my water will be left max I'm sorry, left max minus the height of the building, that is 0, so this will come 1. Now again what I said, my right max is fixed, because I have seen a building height of 2, and right now my left max is 1, which is less than this right max. So I will keep moving my left pointer, so my left pointer will be here now, and I will update my left pointer, that is 2. Now my else case will come and my right max is greater. So now I will calculate height of the building based on the right pointer. So this will be now 2, minimum will be 2 minus height of the building, that is 2, so this will come 0. So I will add 0. Now my right pointer will move here, and water trapped will be right max minus the height of the building, that is 1. So this will come 2 minus 1, 1. So now 1 will be increased, so this will become 2. Now again I will move my right pointer. Now I will update my right pointer, that this will again be 2. Now height of the building is 2, and R max is also 2. 2 minus 2 is 0. 2 plus 0 is 2. Now I will again move right pointer, and my right max will be updated as 3. I'm sorry, I'm having cough. So now I will calculate again. I will see that my left max is less than right max. Now I know I should keep moving left, because my right max is fixed, so the minimum is always going to come the left max. So I will calculate left max, that is 2, minus height of the building, that is 2, so again 0. Now L here, left max is 2, height of the building is 1, 2 minus 1 is 1, and I will increase this by 1. Now again left max. Now height of left max is 2 and height of the building is 0, so 3 plus 2, that is 5. I will say it is 5. Now I'm moving again left pointer. Now height of the left max is 2 and height of the building is 1. 2 minus 1 is 1. I will increase it by 1. Now again L is equal to R. Can we find water if my case is there is only one building? How water can be trapped here? It will overflow. So we can say that we will keep moving our left pointer only when L is less than R. Alright, so we can say we have easily solved this problem now. The answer is coming 6 and the water area is also coming 6. So the logic in the two pointer technique, we can solve with those prefix and suffix arrays also, no problem. But two pointers reducing our space complexity to big O of 1. Alright, and what I did, just if my right max is fixed, if my right max is greater than the left max, so if I move it, I should move left pointer. Alright, and if my left max is greater than the right max, I will keep moving my right pointer and keep calculating the water trapped, though that minimum of left max and right max based on these buildings only. Alright, so I hope you understood. So now I am going to implement this. So first of all, I will say my height of the building is height dot size, and what I said in this two pointer approach, what I have to do first, I have to take two pointers. So my first pointer will be at the first building and my second pointer will be at the last building, and I will store left max and I will also store right max. Now what I said, I will keep moving left and right, and first of all I will update my left max and right max. This will be maximum of left max and the height of building which I have got, that is height of L, and similarly here height of R. Now what I said, if my left max is going to come less than R max, I will keep moving my left pointer. So I should store a variable water to calculate water area trapped. So what will be this? What I told, this will be what minimum of left max and right max, and if left max is coming less than right max, so the minimum will be left max. So this will be left max minus the height of the building, and I will keep moving left pointer. Similarly in the else case also, water plus equals to right minus height of R, it should be L not I. Now keep moving the right pointer, and at the end return water. And we all know that left max minus height of L is always greater than equal to 0, because left max is what? Maximum of height L and left max. So this minimum value will be 0. So if I run this and if I submit this, we have passed these sample test cases, and if I submit this, and we can see we have solved this problem successfully now. And time complexity, we are just iterating once, so time complexity is big O of n, and space complexity, we are not taking any space, we are using two pointer technique, so space complexity is big O of 1. So this was all about this problem. I hope you understood. Thanks for watching. Till then, keep learning and keep upgrading yourself. See you in the next video.